Good evening, students. I am Dr. Manikumar, Mathematics faculty in ACE Engineering Academy. Today, this is GATE booster already started, Okay. Today, we are going to discuss the topic, that is in engineering mathematics, 3 topics we are going to discuss. That is the differential equations, complex variables and numerical maths. Already remaining topics already completed yesterday, Now you see, we will discuss the problems particularly in NAT questions, means numerical answer type questions we will discuss. So this is a problem in differential equation. Say this: if the solution of the differential equation x dy minus y dx is equal to x into root 2 over x square minus y square dx is passing through the point, means what is the meaning? If I solve this differential equation, I will get a solution. That solution represents one curve. If that curve is passing through the point 1, 0, then the value of the integrating constant, if I solve this differential equation, okay, in solution finally we will write integrating constant or not? The value of integrating constant k, just that integrating constant they named it as k, they are asking the value of k. So how to find it? You say this: solution. What is given the, yes, actually square roots also there, it is looking in different manner, but you see x dy minus y dx is equal to, with one simple observation you can convert simply with a small inspection you can solve it easily. This is nothing but x into, say here in root over x square, okay, first I will write this differential equation, that is x square minus y square. That implies x dy minus y dx by x is equal to, that x I am writing like this. So here from x square, see inside the square root you can take x square common. If you take x square common, it will come out as x or not? That is x into root over, that is 1 minus y square by x square. Don't confuse. This x already written here. From this, if I take x square common, it will come out as x. I have written like this. Next step, this is nothing but into dx is there, sorry, dx I have to write. Now say this: x dy minus y dx, that x also you write this side, that is x into x square or not? That is root 2 over 1 minus y by x whole square dx. Say this now. This differential equation I will write it as, that implies in next step how I am writing, you say this: x dy minus y dx by x square by, what is the reason why I am writing like this? I will give you an idea, just a minute. Root 2 over 1 minus y by x whole square. Complete, even that RH right hand side also I am converting like this, is equal to dx. First one observation I will give you. What is derivative of sin inverse y by x? Derivative of sin inverse y by x. First, derivative of sin inverse x is 1 by 1 minus x square or not? 1 by root 2 over, sorry, 1 by root 2 over 1 minus x square. 1 minus x square means y by x whole square. So derivative of sin inverse x is 1 by root 2 over 1 minus x square. In place of x, y by x is there. Again I have to find derivative of y by x or not. So what it is? What is derivative of y by x? X dy minus y dx by x square. This is derivative of y by x. By denominator is nothing but root 2 over 1 minus y by x whole square. Clear? Now, even if they give a differential equations like this, okay, so generally one our basic doubt, sir, shall I convert it, is it possible to convert it into variable separable form? See, not possible to convert it into variable separable form. Okay, it is a non-exact. Is it a linear form? Means y square is there, non-linear. So generally variable separable form not possible, exact not possible, linear form not possible. So that in such case I have to convert non-exact into exact. Okay, lengthy process. Instead of doing like this, simple with inspection. If you practice some problems like this, easily you will get the idea. X dy minus y dx by x square by root 2 over 1 minus y by x whole square is nothing but completely it is derivative of sin inverse y by x or not. So, this is derivative of sin inverse y by x is equal to dx. Is it? Yes. Now, general solution is GS means general solution is integration of derivative of what it is sin inverse y by x is equal to integration of dx plus c. Plus c means here that integrating constant they named as k, so that I am writing it as k. What is integration of derivative is the function itself or not? So, sin inverse y by x is equal to x plus k. This is a solution. But what is given? Yes, this solution means this curve is passing through the point 1 comma 0 or not? Means in place of x1, in place of y, you can substitute 0. x1, y0. Put x is equal to 1, x1 comma 0 means y is equal to 0. So that what it is? That implies 1 implies this is sin inverse of 0 is 0, 1 plus k. Therefore, what is k? K value minus 1. K value there is. K value is minus 1 or not? Okay. So, like this we can solve. Now, coming to the next problem. See, the value of the Wronskian of linearly independent solutions of the differential equation. See, this is one homogeneous differential equation, second order homogeneous linear DE with the constant coefficients. At x is equal to 0, Wronskian of linearly independent solutions they are asking. So, how to find the Wronskian here? What is given differential equation? Given differential equation is, shall I write like this? That is d square minus 3d plus 2 into y, capital D form I am writing. So, this is f of d form or not? So, auxiliary equation you can write, auxiliary equation is f of m or f of d also no problem. In place of d substitute, that is nothing but m square minus 3m plus 2 is equal to 0. m minus 1 into m minus 2 is equal to 0. That implies m is equal to 1 comma 2. These are the roots of, because it is a second order DE, we will get two roots of auxiliary equation. Here both roots are real and distinct. If the roots are real and distinct, what are linearly independent solutions? Linearly independent solutions are, one is e power x, second one is e power 2x. So, what is Wronskian? Suppose one linearly independent solution, you can take it as, okay, I will give the names also. You can take it as u comma v. Linearly independent solutions are u of x is equal to e power x. Another linearly independent solution, you just give a name as v, that is e power 2x. Now, what we are asking? Wronskian of linearly independent solutions. So, for these linearly independent solutions, Wronskian. What is Wronskian? Wronskian W is equal to, Wronskian of linearly independent solution means that is determinant of u comma v. For Wronskian of u and v we are asking. Okay, that is u dash v dash. Clear or not? So, what is u? U is nothing but e power x. Next, this is e power 2x. What is u dash? Derivative of e power x is e power x only or not? So, derivative of e power x is e power x only. This is 2e power 2x. Find the Wronskian means determinant is nothing but AD minus BC or not? 2 by 2 determinant. AD minus BC means what it is? 2e power 3x. Is it? Minus e power 3x or not? Simply e power 3x. But Wronskian at x is equal to 0 are asking. At x is equal to 0, W is equal to what it is? E power 0 or not? 1. Clear? Like this we can. Coming to the next problem. The solution of the differential equation, say this. This is dependent variable x, independent variable t. Okay. So, d square x by dt square plus 1 by t into dx by dt minus x by t square is equal to 1 given. So, sorry, is equal to 0 given. Once observe carefully, if you simplify it, what is given the solution? Given differential equation is, given d is, if you write in capital D form, that is just d square. Here variable is x, not y. Generally dy by dx we are writing, but here x depends on t. Okay, x is a function of t. Simply our final solution is x is a function of t. D square plus, sorry, d square x, d square x plus 1 by t dx, is it? Minus x by t square is equal to 0. That implies t square into d square x, is it? Take LCM, plus td into t dx minus x is equal to 0. This you can write as t square d square plus td minus 1 into x is equal to 0 or not? X means x of t is equal to x is a function of t. Is it a Cauchy-Euler linear D or not? See here, d coefficient is t, d square coefficient is t square. This is variable coefficients. This is Cauchy-Euler linear D, that too homogeneous form is equal to 0. This is Cauchy-Euler linear D or not? Cauchy-Euler linear differential equation. How to solve it? Put x is equal to, generally e power z we are taking or not, but in place of x here t is there. T is equal to e power z. Don't confuse. Here in place of x t is there. In place of y x is there. That implies what is z? Z is equal to log t. Then what is xd? Xd will become theta or not? Already Cauchy-Euler linear D working rule you know. Xd is equal to theta. X square d square is equal to theta into theta minus 1. Let it be 1. This differential equation you name it as 1. So, x square d square written, x is here t or not? Td is equal to theta. T square d square is equal to theta into theta minus 1. Understood? Now, substitute in 1. 1 implies, I am substituting in 1, here you say this. In place of t square d square, I have to substitute theta into theta minus 1 or not? Theta into theta minus 1. Plus td is nothing but theta or not? Plus theta minus 1 into x is equal to 0 or not? That implies theta square minus theta plus theta both will cancel into x is equal to 0. Now, it is constant, it is converted as a constant coefficients problem. F of theta y is equal to 0 form. So, how to solve this? Now, it is a constant coefficients model. How to solve auxiliary equation? AE is f of m is equal to 0, means f of m is in place of theta m square minus m is equal, m minus 1 is equal to 0, means m is equal to plus or minus 1 or not. So, roots are real and distinct. What is general solution? Z is equal to x of z. X is a function of z or not? C1 e power z plus C2 e power minus z. Therefore, x actually function of t I have to write. C1, what is e power z? E power z you have assumed as t or not? So, C1t plus C2 into 1 by t or not? Let it be 1. But conditions given here. So, one of the condition derivative also there. So, find its derivative too. What is x dash of t? X dash of t is equal to, find its derivative. So, that is C1 minus C2 into 1 by t square. Derivative of 1 by t is minus 1 by t square or not? Let it be 2. That's it. Now, substitute the given condition. Given x of 1 is equal to 1. Given x of 1 is equal to 1. Substitute in 1. 1 implies input x1, input t1, output x of t also 1. Here 1 is equal to, say this, input and output both are 1. So this is C1 plus C2 or not? C1 plus C2. And one more condition given x dash of 1 is equal to 0. X dash of 1 is equal to 0 given or not? So 2 implies, substitute in 2. So output 0, input 1. This is 0. Input 1 means that is C1 minus C2. Let it be 3, let it be 4. From this you can find C1, C2. What is C1? If I add these two, C2, C2 will cancel. C1 is equal to 1. Okay, from 3 and 4 directly I am writing. Okay, 3 plus 4 implies C1 is equal to what it is? If I add these two, what it is? 2C1 is equal to C2, 2C1 is equal to 1. That implies C1 is equal to 1 by 2. C1 1 by 2 means C1 minus C2 is equal to 0 means C2 is also 1 by 2. Therefore, from 1, what is solution? X of t is equal to, what is x of t? C1t. C1 is 1 by 2t plus 1 by 2t plus C2. C2 is nothing but 1 by 2, 1 by 2t. Now, what is the tail end of the question? The value of x at t is equal to 1 required. Now, x of 1 is equal to, what is x of 1? 1 by 2, substitute t is equal to 1, that is 1. Clear or not? With initial conditions given here, using these conditions we have to solve like this. Okay? Now, see this question. This is from complex variables. This is also NAT question. The value of integral c e power z plus sin z by z minus 4 dz, where c is an ellipse. So, around the ellipse means c, along that path we have to integrate. So, what is that path? This is a closed path, that is elliptical path. Elliptical path shape also given, that is what it is. See, x square by 4 plus y square by 9 is equal to, y square by 9 is equal to 1 means major axis is along y axis, minor axis is along x axis. Maybe like this or not? Approximately I am drawing rough diagram. So that this is x square, this is 2 minus 2. This is 3 minus 3 or not? Clear? This is a ellipse. This is a path C given like this. Path C moving in counterclockwise direction generally. Say this. But here what is the singular point? Here z is equal to 4 is a singular point. Yes, very clear. For the whole function, z is equal to 4. If I means at z is equal to 4, function fails to be analytic. Function is not analytic at z is equal to 4. Z is equal to 4 is a singular point. Clear? Lies inside the curve, lies inside this path or lies outside the closed path. Clearly, z is equal to 4 appears here, it lies outside. Okay, lies outside in the sense there is no singular point inside this closed contour. Okay, z is equal to c is a singular point, lies outside C. Clear or not? If there any singular point lies inside C, then I will apply Cauchy integral formula, already you know. But there is no singular point lies inside. The one singular point you have observed, but it lies outside the closed curve in the sense, no doubt by Cauchy's theorem, answer is directly 0. Therefore, by Cauchy's theorem, what is the Cauchy's application? Not integral formula. If any singular point lies inside, then integral formula will apply. Integral C, that function, total function sin z by z minus 4 dz is equal to 0. Understood? Clear? Coming to the next problem, the coefficient of 1 by z in the Laurent series of f of z, okay, Laurent series of the function in this region. So, I have to expand that function using Laurent series within this region. In the region, first I have to expand. After the expansion, I have to find the coefficient of 1 by z. How to expand using Laurent series? Solution. What is given function? F of z is given as 1 upon z minus 1 into z minus 2. So, but already you know some standard forms. Standard form means 1 minus z whole power minus 1 expansion. Okay, in Taylor series expansion of 1 minus z whole power minus 1 plus z square plus z cube plus infinite series like this or not. Okay, so this is valid. What is convergence region for it? What is ROC for it? This is valid in the region mod z less than 1 or not? Similarly, this is valid in the region mod z less than 1, and similarly 1 plus z whole power minus 1 is nothing but inside minus all are positives, inside plus means alternate positive and negative, 1 minus z plus z square minus z cube plus and so on. This is also valid in the region less than 1. Clear? Now, I am going to use these expansions for this function. So, how? See, to use these expansion, to use this Taylor series expansion, first you resolve into partial fractions. Why? This expansion is given for the single factor, but here product of two factors are there. If you resolve into partial fraction, then it is possible to use them. So, what I will do? F of z is equal to, as numerator constant only you can guess, 1 by z minus 2 minus 1 by z minus 1. Is it correct or not? You check it. So, that z minus 2 into z minus 1 denominator. Now, what is numerator? Z minus 1 numerator, z minus 1 minus z minus 2 by z minus 1 into z minus 2. Z will cancel, minus 1 plus 2 will get 1 only or not? So, this and this are both are same. You can write like this. So, simply partial fractions, without doing partial fractions we are guessing, that is it. Now, this you can. Now, in this region I have to expand. Say this, in the region, in ROC, in the region 1 less than mod z less than 2. What is the exact meaning? In this region only I have to expand in the sense, you say this. Here 1 is less than mod z and mod z is less than 2. For both of them center is 0. Say this, center is 0 only for both of them. Mod z less than 2 means what is the diagrammatic view? Say this. First, 1 less than mod z means mod z greater than 1 or not? That is mod z greater than 1 and mod z less than 2 means all values of z with center 0. Say this, center is 0. Meaning is, what is the diagrammatic view? Center 0. This is 0. With center 0, radius 1. Mod z greater than 1 meaning is all values of z above the radius 1. Suppose this is the radius 1. All values of z above the radius 1. I will change the color. Okay. This is 1. All values of z above the radius with center 0. These are z's. Every z is above the radius. Exact meaning, diagrammatic view I am giving. And mod z less than 2 means, see, above the radius 1 and below the radius 2. Okay, above the radius 1 and below the radius 2 means, yes, diagrammatic view is like this only. All z's. This is nothing but again 2. Just for clarity. Means 1 less than mod z less than 2 means it is annulus. Annulus means ring shaped region. So, we can denote it as 1 with center 0. Z means z minus 0, z minus a less than 2. Here 0 is a center. 1 less than mod z less than 2 means all values of z which lies between these two concentric circles. Okay. So, above the radius 1 and below the radius 2. Clear? Now, within this region I have to expand Laurent series. Without using Laurent series definition and without using Laurent series theoretical view, how to expand directly? One simple technique. See, above the radius 1 means, all powers of z means if you expand above the circle, means that expansion contains negative powers of z. Already you know this, that expansion contains negative powers of z means every power of z must be negative only. You should not observe single positive power also. So, above the radius 1 means this part. So, above the radius 1, if I expand above the radius 1, I have to observe negative powers only. Negative powers means corresponding to radius 1, this is a factor or not? This is a factor. So, you can take z common here. If I take z common, by default, I will get a negative powers only. Is it? Here in this term, you can take z common and directly use them. That's it. No need to use the Laurent series basic definition for it. And next, see, this is below, before, see this, below the region. This is above the region, this is the below the region. So, with up to there, see, after 1 and before 2. Before 2, see, before 2, I have to expand using Laurent series means every power of z must be positive power. Positive power means where 2 is presented, this radius is 2 or not? Where 2 is presented here, you can take constant common here. If I take constant common, we will get the positive powers. If I take z common, you will get the negative powers. Already you know this information, simply it is a, it is a booster class. Just it is a recollection of your knowledge only. Yes, for negative powers, I have to take z common. Once again I am telling, for positive powers, I have to take constant common. Okay, where negative powers required? See, above the radius 1. So, where 1 is there, you can take z common. By default, I will get negative powers. Where positive powers required? Below the radius 2. So, where 2 is there, you can take constant common. Okay, so and then you can use them. How? That implies, this step I am continuing, say this. That implies f of z is equal to, what is f of z now? F of z is equal to, see what is the previous one, 1 minute. 1 by z minus 2, once again I will write 1 by z minus 2 minus 1 by z minus 1. Okay, 1 by z minus 2, already I told you, where constant common and where z common? Yes. Here constant common, here z common. So, 1 by, if I take minus 2 common, 1 minus z by 2. We will get positive powers only. Why I am taking common like this means to write like this, 1 minus z form or 1 plus z form. Already you know. Here you can take z common, 1 minus 1. By default I will get negative powers only. So, that implies what is f of z? F of z is equal to minus 1 by 2 into 1 minus z by 2 whole power minus 1. Minus 1 by z into 1 minus 1 by z whole power minus. Minus 1 by 2 into, this is in a form 1 minus z whole power minus 1. What is 1 minus z whole power minus 1 expansion? 1 plus z, 1 minus z whole power minus 1 expansion, this one. In place of z, z by 2 is there or not? 1 plus z square. Even if you apply by using Laurent series formula also, you will get the same answer, infinite series. Minus 1 by z into, again this is also in a form 1 minus z whole power minus 1. What is 1 minus z whole power minus 1 expression? Same. 1 plus 1 by z plus 1 by z whole square plus and so on. Now, this is an expansion file. But what is our question here? Coefficient of 1 by z required. 1 by z or 1 by z square? My question is coefficient of 1 by z. Yes. What is coefficient of 1 by z? Here 1 by z form is not possible because all these are the positive powers of z only. Here only 1 by z. Yes. Here first term is minus 1 by z. Second is 1 by z square, 1 by z cube, like that. What is the coefficient of 1 by z? Minus 1 is an answer. Clear or not? Okay. Now coming to the next question. This is related to the numerical methods. The real root of x square minus 1 is equal to 0 can be approximated using Newton-Raphson method. Okay, NR method, Newton-Raphson method. If the initial guess x naught is given as minus 1, Next guess x1 is nothing but x0 plus h, then the value of h. Simply h is nothing but the gap between x0 and x1. Okay, already x0 given. Find x1, you just find the difference of x1 and x0. By NR method, what is the formula of NR method? Solution. But given, what is given function? F of x is equal to given. You can take that function f of x as nothing but x square minus 1. Is it? What is x0? Yeah, for NR method I have to find the derivative also. What is x0? F dash of x, first you find f dash of x, 2x. What is x0? Initial guess x0 given or not? X0 is equal to minus 1 or 1? Minus 1. What is NR method formula? NR method means Newton-Raphson method. By NR method, what is x1? x1 is nothing but x0 minus f of x0 by f dash of x0 or not? That implies x1 is equal to, what is x0? Minus 1. x0 is minus 1. What is f of x0? So, f of minus 1 by f dash of minus 1. Is it? Is it? Now, coming to substitute, therefore, what is x1? x1 is equal to minus 1. Minus what is f of minus 1? Substitute f of minus 1, if I substitute, I am getting 0 or not? F of minus 1, if I substitute, I am getting 0. Is it? Yes, minus 1 whole square is 1 minus 1, 0. F dash of minus 1 is nothing but minus 2. Is it? So, x1 is also you are getting same minus 1. Any mistake? So, f of minus 1 I am getting 0. So, f dash of minus 1 is nothing but minus 2 or not? So, what is x1? x1 is also I am getting minus 1. x0 is given as minus 1, x1 is also minus 1. So, what is h? Given h is equal to x1, x1 is equal to x0 plus h. Okay, one step I will write. Given x1 is equal to x0 plus h. That implies what is h? x1 minus x0. What is x1? x1 is minus 1, x0 is also minus 1. You are getting 0 or not? Therefore, h is equal to 0 at this step. Okay, here h is equal to 0 only for this particular case. Okay. Right. Now, coming to some MSQ questions, means multiple select questions, we will discuss on these three areas. You say this. Which of the following functions is entire function? First one. What is the meaning of entire function? In complex variables, a function which is analytic everywhere on whole complex plane. Whole complex plane means in all quadrants. So, everywhere without any break. So, everywhere in all four quadrants if it is analytic. Okay, analytic everywhere on whole complex plane, that type of function we call it as entire function. Already particularly in analytic functions topic, some standard analytic functions will give. That is, one is sin z. Sin z is an entire function, it is analytic everywhere. Okay, even exponential function is also analytic everywhere. Already standard analytic functions is that. This is a polynomial function. Polynomial functions also analytic everywhere. So, these three are standard entire functions. Now, the fourth one is a doubt. Cot z, is it entire or not, is a doubt. Suppose f of z is equal to cot z. If I take cot z is nothing but cos z by sin z or not? Yes. Suppose see this denominator at sin 0, z is equal to 0, denominator 0, function fails. Function fails means derivative fails. Derivative fails means analyticity fails. At z is equal to 0, plus or minus pi, plus or minus 2 pi. All these are the failure points. Failure points means singular point. At 0, plus or minus pi, plus or minus 2 pi, function fails to be analytic. Means all these are singular points. So, function fails to be analytic means how can you say it is entire? If it is entire means analytic everywhere. But clearly you are observing some singular points means at all these singular points analyticity fails. So, it is not entire function. Clear or not? So, which of the following are entire means options A, B, C are correct. Understood? Now, coming to the next one. See, For an analytic function f of z is equal to u of r comma theta plus I into v of r comma theta. Imaginary part is given. Which of the following is correct? Okay. So, imaginary part given. Function analytic given. U of r theta plus I into v of r theta means this is a function in polar form, not in Cartesian form. Here the coordinates are not Cartesian coordinates. See, here the coordinates are polar coordinates. So, verify from the options, very clear. So, if f of z is equal to convert it into Cartesian to polar form, you will get the idea. Already we given or not. So, first option is it satisfies or not, I will check it. From option A. From option A, if I take f of z is equal to log z, but log z you write in polar form because the function given in polar coordinates. From option A, I am taking like this. If I take f of z is equal to log z, log z means log of what is polar form of a complex number? R e power I theta or not? Polar form is R e power I theta or not? That is log r plus log of e power I theta or not? So, that is nothing but log r, very clear. Log of e power I theta is I theta or not? So, very clear. This is a real part u plus I into imaginary part v. Plus I into imaginary part v. This is v. Okay, theta v is v here. Understood clearly. So, for an analytic function f of z is equal to u of r comma theta plus I into v of r comma theta. If the imaginary part v is theta, yes, theta. For log z only, for the function log z only, you have got the imaginary part theta. So, f of z is equal to log z is a corresponding analytic function. So, option A correct. U of r comma theta, u of r comma theta means real part is log r. Yes, this is also correct. Okay. Now, f of z is equal to log z is correct means f of z is equal to log z if it is correct. What is its derivative? Derivative is 1 by z or not? F dash of z is 1 by z, that is also correct. F of z is 1 by z is wrong. Already f of z is equal to log z we have verified. Understood? So, here which options are correct? A, B, C, all three options are correct. Clear? Now, coming to the next problem. See, if there are m number of data points in a plane, how many data points in a plane? M number of data points in a plane. Say this. This question is related to numerical methods, that to concept based question. Say this, concept based question, read it carefully. If there are m number of data points in a plane, then the interpolating polynomial which fits these m data points has which of the following which of the possible degree? Means very clear. See, already you know, suppose there are n data points in a plane. Suppose there are n data points, here m data points given in place of n, generally m data points. Means m data points means what is the meaning? x0, y0, x1, y1, like that. If you continue start with x0, y0 better. M data points. First one is x1, y1. Second one is x2, y2. Next xm, ym. Like that, there are m number of data points. If there are n data points in a plane, what is the best fitting polynomial which fits these given data points? This is a concept of interpolation, already you know. Suppose there are 4 data points in a plane, the best fitting polynomial which fits the 4 data points is a polynomial up to degree 3. 4 data points means the maximum degree of a polynomial is 3. 5 data points means the maximum degree is 4. Okay, already you know this concept. If just 2 data points in a plane, okay, which type of curves you can draw? The unique curves, either a straight line, unique curve, straight line like this. If there are two data points in a plane, yes, we can best fitting curve is a straight line. Straight line is a linear polynomial, that is a0 plus a1x or not, first degree polynomial. So, if there are two data points in a plane, the best fitting curve passing through two data points is a straight line. Straight line is a polynomial. Is it right or not? Straight line is a polynomial. Is it? You can draw a straight, 1 minute, one clarification again. Straight line means here, I can draw straight line like this, means two types of straight line. This is a straight line with no slope. Straight line with no slope means it is a constant polynomial or not? Okay. This is a straight line with some slope, means that is f of x is equal to, I will start from the straight line itself. I will give more clarity from this. Yes. F of x is equal to a0 plus a1x. This is a straight line. See this, very clear. If there are two data points in a plane, the best fitting curve is a straight line like this with no slope, means with slope 0, and a straight line like this with some slope, maybe like this or maybe like this. If it is a straight line like this is a polynomial with degree 0 or not? This is a polynomial with degree 0. This is interpolation concept already you know. If it is a straight line like this is a polynomial with degree 1. Is it a polynomial with degree 1 or not? From this, what is the conclusion? If there are two data points in a plane, the best fitting curve is a polynomial, either a polynomial with degree either 0 or 1. Either 0 or 1 means up to degree 1. For two data points, briefly I am writing. For two data points, interpolating polynomial, means fitting curve is nothing but interpolating polynomial, degree is up to 1, not exactly 1, up to 1, maybe 0 or maybe 1. Understood? Suppose if you take three data points like this, if I take three data points like this, if you take three data points I am taking like this, just for clarity. If you take three data points, if in three data points we can, here also you can draw a straight line. Is it straight line we can draw like this? Straight line you can draw, if it is a straight line with no slope, that is nothing but f of x is equal to k or not, three data points. Or three data points may be like this, the position of the data points are like this. Here also we can draw a straight line, but straight line is not a constant polynomial here. What it is? That straight line is nothing but a linear, that is a0 plus a1x with some slope. But three data points may be like this also, need not be in straight form. If the three data points are like this, 100% we have to draw the curve which is passing through these data points, means compulsory it is a parabolic shape. What is parabola? Second degree polynomial. F of x is equal to a0 plus a1x plus a2x square. Now from this observation, yes, if three data points, for three data points, if there are three data points in a plane, for three data points, just briefly I am writing, for three data points, what is the best fitting curve passing through three data points? That is interpolating polynomial degree, interpolating polynomial degree is up to 2. Is it? From this one clarification. For two data points, up to 1 means maximum degree, either 0 or 1, maximum degree is 1. For three data points, up to degree 2. Similarly, if you continue for 4 data points, up to degree 3. For 5 data points, up to degree 4. For n data points, up to degree n minus 1. Now, coming to the question. For m data points, okay, m data points, what is the maximum degree? Maximum degree is m minus 1, not exactly. Degree may be m minus 1 or less than m minus 1 also. So, degree may start from degree 0, it may start from degree 0 like this. That is, degree 0 or degree 1 or degree 2 up to degree m minus 1. So, what are the possible degrees? That is why exact degree I am not asking here. Possible degrees only. What are the possible? M not possible. Maximum degree is m minus 1. So, m minus 1 possible. M minus 2 possible. M minus 3 also possible. So, which options are correct? B, C, D are correct. Understood or not? Say this. Consider the differential equation dy by dx is equal to y minus x with initial condition y of 0 is equal to 1. Which of the following statements are correct? Okay, first say this is a differential equation. Which of the following statements are correct? Say this. One is forward Euler's formula. Forward Euler's formula used is y of n plus 1 is equal to yn plus 1 is equal to which of the following is correct for just one information, not yet a typo error in one small information. Which of the following is correct for? I will write that. Which of the following is correct for forward Euler's method? Actually, it also been there, but some typo error. I am adding that. Which of the following is correct for forward Euler's method? You say this. Forward Euler's formula used is yn plus 1 is equal to, because the first you should know the formula. Yn plus 1 is equal to yn plus h into f of x and yn. F is not this, some type. Yn plus 1 is equal to yn plus h into f of x and yn. F is missing. This is f of x and yn. Yes, so f is missing. Sorry. So, f of x and yn, so option C is correct. So, local truncated error. What is truncated error formula? What is actually Taylor series? Generally, to find the truncated error, we are comparing with the Taylor series already, you know. What is forward Euler's method? y1 is equal to y0. Using y0, how to find y1? y0 plus h into f of x0 y0. This is forward Euler's method formula. But what is Taylor series method formula? By Taylor series already you know how to calculate the truncated error. By Taylor series, y1 is equal to y0 plus h by 1 factorial into y0 dash plus h square by 2 factorial into y0 double dash plus and so on. Okay, for more clarity, okay, one more step I will write. H cube by 3 factorial into y0 triple dash plus and so on. See, observe carefully here. Generally, dy by dx we are writing as f of xy. Is it? Dy by dx means y dash or not? Y dash is equal to f of xy or not? So, what is y0 dash? Y0 dash is nothing but f of x0 y0. Just a notation only. So, this is nothing but this you can write as y1 is equal to y0 plus h into f of x0 y0 you can denote it as y0 dash or not? Y0 dash. Both are same. Don't confuse. Now observe carefully. Actually this is a Taylor series formula. y1 is equal to y0 plus h by 1 factorial into y0 dash. What it is? It is forward Euler's formula or not? Forward Euler's formula. From here onward, means if I solve one problem with Taylor series, there is a possibility to add number of terms like this. But if I use forward Euler's formula, I have to stop here only. Means from this step onwards, complete this part is a truncated error of forward Euler's method or not? So what is truncated error? Truncated error is nothing but, in forward Euler's method, truncated error is nothing but. So it starts from h square by 2 factorial into y0 dash plus h cube by 3 factorial into y0 double dash y0 dash plus h square by 2 factorial into y0 dash plus h cube by 3 factorial into this is y0 double dash y0 triple dash plus and so on. So error starts from h square term onwards or not? we can denote it as big O notation of h square. We can denote as big O notation of h square. We also call it as order of h square, you know that. So, what is truncated error? Error starts from h square term onward. Notation is big O notation of h square. That truncated error is big O notation. There it is. This is a formula here. F is a typo error. Actually, F is also there. Actually, I will write it. Yn plus 1 is equal to Yn plus h into f of x and y. So, C is correct. Local truncated error big O notation of h square is correct. Now, A or D. Y of 0.1 value, is it 1.1 or 0.2? I will check it. So, here, 1 minute. Y of 0.1 also I have to check. Say this. Already y of a, to verify the first condition, y of 0, first or fourth one which is correct, y of 0, d given d is, for that I am verifying like this. Given differential equation is, given dE is, dy by dx is equal to y minus x, y minus x. Initial condition given. What are the initial condition? Y of 0 is equal to 1. Given y of 0 is equal to 1 means input x naught is 0, output y naught is equal to 1. Y of 0.1 they are asking, that is our question mark. So, that is x1 required. x1 is 0.1. y1 I have to find. What is h? h is not given separately, so that you can take the gap between x1 and x0, you can take as h. h is equal to x1 minus x0, that is 0.1. If they give h accordingly, I have to follow, but h is not given means I am taking 0.1. Now, by forward Euler's method, what is the formula? By forward Euler's method. By forward Euler's method, what it is? y1 is equal to y naught plus h into f of x naught y naught. So, what is y? This is the general formula, yn plus 1. In place of n, if I take 0, y1 is equal to y naught plus h into f of x naught y naught will come. In place of n, if I take 1, y2 is equal to y1 plus h into f of x1 y1 will come. That is a general formula. What is y naught here? Y naught plus h into f of xy is nothing but f of xy is, this is this y minus x means this is f of xy. F of xy is y minus x. So, f of x naught y naught, f of xy is y minus x means f of x naught y naught is nothing but y naught minus x naught. What is y naught? Y naught is already given as 1. 1 plus h is 0.1, 1 minus 0. So, 1 plus 0.1, 1.1. Therefore, y1 is equal to y of 0.1, that is nothing but 1.1. Is it? So, option A also correct? Option A, option B, option C, all these three are correct. So, it is wrong. Understood? Now, coming to the next problem. For a differential equation, d square y by dx square minus 5 into dy by dx plus 6y is equal to e power minus x plus 2. Which of the following are correct? This is non-homogeneous. Non-homogeneous type 1 or not? Type 1 means, I will give more clarity. What is given d? Given differential equation is, right, I will write in capital D form, d square minus 5d plus 6 into y. Why it is not going to back? What the differential equation? It is not going back. Some technical issue. Previous slide is not opening. Just let me check. Okay. Okay, so sorry for the interruption, a small technical issue. Now it was resolved. Okay, let me solve this problem also. For a differential equation, say this is non-homogeneous differential equation given. Okay, d square by d square means that is d square minus 5d plus 6 into y is equal to e power minus x plus 2 you can write as e power minus x into e power 2 or not. So it is type 1 e power ax model or not. So this is f of d. So auxiliary equation directly f of d form I am writing. Auxiliary equation is f of m, actually I have to write. Okay, f of d also no problem. That is d square minus 5d plus 6 is equal to 0. What are the roots? D minus 2 into factors are d minus 2 into d minus 3 is equal to 0 or not? D is equal to 2 comma 3 are the roots. So what is this, since it is non-homogeneous, first I have to write a complementary function. Yc is equal to c1 e power 2x plus c2 e power 3x or not? Okay, next I have to find the particular integral. For particular integral, what it is? Pi is yp is equal to what it is? 1 by f of d of q of x. What is q of x here? E power minus x into e square. E square is with this integrable operator, I have to operate on this. What is that integrable operator? That is nothing but 1 by f of d that is nothing but 1 by what it is? 1 by f of d. F of d is nothing but d square minus 5d plus 6 into e power minus x into e square. So this is in a form e power x or not? Type 1 model. So what is a in place of a? Minus 1 is there. Substitute directly here. That implies yp is equal to what it is? E power minus x into e square by f of minus 1. F of a you have to substitute in place of f of d. What is a here? Minus 1. If I substitute minus 1, this is e power minus x plus 2, you write as usual. F of minus 1 means substitute. Minus 1 whole square is 1. 1 plus 6 is 7. Okay. 7 plus 5, say this. Minus 1 whole square is nothing but 1. 1 plus 6, 7. 7 minus 1 is nothing but 7 plus 5, 12. Is it any mistake in this? 7 plus 5, 12. Therefore, general solution is y of x is equal to yc plus yp. What is yc? c1 e power 2x plus c2 e power 3x plus e power minus x plus 2 by 12. Any mistake? Clear or not? Minus 1, that is 1 plus 6, 7. 7 plus 5, yes, 12, correct. So now which of the options are correct? Which of the following are true? E power 2x and e power 3x are linearly independent solutions of, yes, this is correct. E power minus x plus 2 by 2 is a particular integral, wrong. E power minus x plus 2 by 12 we observed, but it is 2, wrong. General solution, here also same 2 given, wrong. Maybe some typo error also, maybe it may be 12, anyhow 10. So only option A is correct. Suppose if it is 12, then B also correct. If it is 12, B and C both are correct. Clear or not? Okay, right. These are some booster questions in today's session in differential equations, numerical maths and complex variables topic. Is there any class today? Any doubts you have? Right. Now you say this. This is a revision series. Generally every year we are conducting the revision series. It starts from 10th January. Okay, daily 5 to 6 hours, 6 hours of slot it is. It starts from 7 o'clock in the morning. 15 to 20 days these revision classes will conduct. Okay, so use them definitely, means all important topics will cover in this revision series. So generally for use coupon code, that is gate 2020 gate 26 To get a 30%, use that coupon code also and scan QR code for it. And this is pre-gate 2026 exam, forenoon session and afternoon session for 2 branches. You see that. Okay, forenoon session from 9:30 to 10:30 and afternoon session from 2:30 to 3:30. Okay, pre-gate exam. Okay, so for registration, that scan that QR code. Okay, right. All the best, all of you.